Okay, you should know that the stationary points on a curve are the points where the gradient is 0, because you're talking about points where the curve, the tangent to the curve is a horizontal line, so the gradient is 0. So what we're trying to do is we're trying to find the gradient of this line and where the gradient is 0. So to find the gradient for a curve is always dy by dx, and in this case dy by dx, we bring down the 3x power goes down 1, so 3x squared minus 3x, or the x is just going to disappear, and if we differentiate 1, we just get 0. So the gradient is 3x squared minus 3. Now, to find the stationary points, we're going to put that equal to 0. So 3x squared minus 3 is equal to 0. Well, that just means that 3x squared is equal to 3. So x squared is equal to 1. So x could be plus or minus 1. So 1 or minus 1. Now, when x is equal to 1, because we're trying to find the stationary points, I'm going to find the y-coordinate as well. When x is 1, y is going to be 1 cubed minus 3 plus 1. So that's going to be 2 take away 3, which is minus 1. So one of the stationary points is at 1 minus 1. When x is equal to minus 1, let's work out what y is again. So y is going to be minus 1 cubed minus 3 times minus 1. Well, that's plus 3 plus 1. Well, that comes out as minus 1 plus 3 plus 1, which is 3. So our other stationary point is at minus 1, 3. Now it asks us to identify which is a maximum and which is a minimum. Now there's two different ways of doing this, well, at least two. One of the ways of doing it is to think about the shape of the graph. Now the graph is a positive cubic, which means it starts with a positive gradient, it's going to go down like that, and then it's going to go up. Logic tells us 1, minus 1 and minus 1, 3. This point here, because minus 1 is further left than 1 on the x-axis, this point here must be minus 1, 3, and this one here must be 1, minus 1, which means that 1 minus 1 is the minimum, and minus 1, 3 is the maximum. Okay, so you could use the graph. The alternative way is to differentiate again, so you find d2y by dx squared. Now if we differentiate this, well, 3 times 2 is 6, so we get 6x. Now, when x is equal to 1, the second derivative there, so d2y by dx squared is equal to 6 times 1, which is 6. Now, because that's positive, that means that we have a minimum. Remember, it's the opposite way round to the way you'd expect. Second derivative positive means a minimum, and then when x is equal to minus 1, then d2y by dx squared this time is going to be 6 times minus 1, which is minus 6, which is obviously negative, which means that that point there is a maximum. Okay, we're now asked to sketch the curve. Well, I've pretty well already done that, haven't I? Here we have the axes. We've got 1, minus 1, where you've got a minimum. Okay, so there, sorry, wrong place. Okay, there's 1, there's minus 1, so we've got a minimum there, and minus 1, 3, so let's get rid of that. There's minus 1, 3 is up here, and we have a maximum there. So the curve is going to come up something like this, then it's going to go down through the minimum, and there it is.